So welcome everyone, and thank you all for coming today. I'm Lorraine Chalafour. I'm the Associate Dean, or one of the Associate Deans of Graduate and Postdoctoral Studies here at McGill, and I'm honored to be host of the 2019 CAGS Eastern Regional 3-Minute Thesis Final competition. CAGS, of course, means the Canadian Association for Graduate Studies. The presentation at McGill of the 3-minute thesis this year were just fascinating. So I'm really excited to see, and I've just met the best of Eastern Canada here, and I'm excited to hear what they have to say to us. Welcome to all of those participants who traveled from far, Newfoundland, and not so far, Concordia, to come to this competition. We hope that you enjoy your time at McGill so far and that you continue to enjoy it. And we also want to welcome our audience today, those present and those visiting online. Before we begin, I'd like to acknowledge that McGill is located on land which has long served as a site of meeting and exchange amongst Indigenous peoples, including the Haudenosaunee and the Anishinaabe nations. McGill honors and recognizes and respects these nations as the traditional stewards of the lands and the waters on which we meet today. As for anything, there's rules. Notes for the audience, please turn off your cell phone. I don't want to hear any ringing in the middle of a punchline of somebody. You can take a picture or a photo with your phone or elsewhere, but don't use the flash. Also, you should have a ballot for the People's Choice Awards. You should have it in your hand. If you don't, go get one. You will have to submit these at the end while the judges are judging themselves, and we'll get to the judges in a moment. And for those of you online, we'll give you a link so you can also vote online as to who you think is your people's choice. For the competition overview, the 3MT is a research communication competition developed originally by the University of Queensland in Australia in 2008. It's now hosted internationally in over 600 universities in 65 countries, so we're on to a good idea. In the competition, graduate students have 3 minutes, no longer, to present a compelling oral presentation of their thesis and its significance to a non-specialist audience, using a single static slide, which means there's no movements or animation on the slide. There's some rules to keep in mind, like anywhere else. They're not allowed notes, no props, no costumes. They're not permitted to use any audio files or technology, no whiz-bangs on their single slide. The presentations must be spoken, no rap, no dance, no poems. Any presenter that goes over 3 minutes will be disqualified. And we have Sarah here, who is manning the timer. She's down there. And the presenter can see how long they have, just to be fair. The decision of the judges is final. In Canada, the English competition is sponsored by the Canadian Association for Graduate Studies. All of today's grant presenters were selected by their institution to compete in this regional competition. 3 winners from today will advance to the CAGS finals, which is hosted virtually. So their recording today is it. The video from today is what will be submitted to this final. There are 2 other regional competitions in Canada. Both of these were hosted April 17th. 5 candidates have been selected from Ontario, and 3 candidates were selected from the western provinces, Manitoba, Saskatchewan, Alberta, and BC. This gives a total of 11 finalists. Those are videos that you can watch on the CAGS final virtual in June. We'll tell you or send you a link to that email when we have a specific date. So our presenters. We have 11 presenters as noted here, and you should have got a sheet from the desk out front with their photos and where they're from. So they come from the Maritimes, Newfoundland, Quebec. I can't wait to hear what they are. I met them at lunch and it sounds really fun. Their subject matter, it covers a wide research areas. I'll tell you a bit more about each of them when we come to present them. And just for everyone to know, they're going to come on stage. They'll one at a time. They'll present. I'll allow the judges about a minute and a half or so to, and we'll try and be quiet so they can concentrate. So to get their criteria, and I'll explain about what the criteria are. When all the finalists and all the presenters have made, I'll ask the judges to leave for another room where they can deliberate and get down to a 3, which I imagine will be a tough choice. The rest of us can take a 10-minute break. And what we can do at that point is you can try and figure out for yourself who you would like to have for your People's Choice Award. So pay attention and mark down as we go along which one you think is the one to go. So as for judges, we have 3 judges today, and I'll ask them to wave when they hear their name called. So the first is Sonia DiMallo. She's a MA and CRP, founder of Harvest Performance. She has 20 years of experience cultivating trust, inspiring connections, and harvesting the results. As a global leadership innovator, she uses positive communication and positive education skills that she's gleaned from her award-winning Ken Blanchard endorsed book, An Apple in the Orchard, to impact people, places, and communities. She's a proud mom of 2 teenage boys, enjoys travel and dark chocolate. Connect with her via www.soniadimalo.com. Mark Levine is an entrepreneur, investor, and philanthropist who is passionate about developing entrepreneurial talent, in Montreal especially. He led a successful career as an electronics and software company to acquisition. He then stayed on as a senior director of product management to help drive a broader product and innovation strategy. Currently, he's involved with several McGill entrepreneurial initiatives and is always eager to volunteer his time to help foster McGill talent. No conflicts here. Christos Syros was born in Athens. He graduated from McGill. He then was a teacher, guidance counselor, and director general of the Park Extension CLSC in Montreal before being elected to the Quebec National Assembly in 1981. He served 6 terms as an MNA, so he's got stamina, and was Minister of Native Affairs and Natural Resources. On leaving politics in 2004, he was appointed Quebec delegate general to Brussels and the European Union between 2004 and 2012, and subsequently served as the Quebec agent general to the UK and Nordic countries until 2017. So thank you all for the judges for being here today. Prizes. This is money. Our prizes will be the judges will be awarding 3 different prizes. As mentioned, the first, second, and third place will go to the CAGS final. Each of these, they'll be judged in now. All of you in the audience will have a chance to get their People's Choice Awards as well, and they also receive some bucks, so pay attention. For criteria. So the judging criteria here, and what the judges will use to decide who is that first, second, and third place, is so that the presenter will have clear communication skills, comprehensive and understandable summation of their thesis, and an ability to engage the audience and really teach them about their research. After the last presenter and a short break while the judges are deliberating, there'll be a Q&A period as well. So while you're thinking about what you thought about this person and their skills, you could be thinking about a question to ask them too. You could write it on your ballot. You, the audience, want to consider these same 3 criteria when you're choosing your favorite. Remember that the talk is not necessarily about the research itself. It's about how the presenter disseminates that information. So, right now, I'd like to present the first speaker. So, Nusha Arezu is a master's student year 2 in the Concordia University in chemistry and biochemistry. She got her BSc in North Nottingham, the Malaysia campus, in pharmacy. She here is going to talk about her research on the laboratory of polymer and nanoscale biomaterials chemistry at Concordia. She works on the development of an intelligent dual stimuli responsive drug degradable nanocarriers for online delivery of chemotherapeutic drugs. When she's not working on this, she likes to dance. She likes to watch the Iranian Soccer League. So, Nusha, please.
I met a 6-year-old girl, Amy, who's been living with leukemias, cancer of blood-forming tissue. She's been going through chemotherapy for more than 2 years, and her biggest dream is to have beautiful long hair just like her Barbie doll. Cancer is a nasty disease. It kills more than 8 million people every year, which explains why billions of dollars are spent on cancer research annually, and apparently, we still don't have a cure for it. But the truth is that we do. There are many drugs discovered that can successfully kill cancer cells. But the problem is that most of them are not selective, which means that they can kill cancer cells as well as healthy cells, and therefore lead to unwanted side effects, including the hair loss. My research focuses on designing intelligent drug delivery carriers that can deliver the drugs to the cancer tissue, but not to the healthy tissue. You can think of it as a nano-sized pizza delivery man that is carrying the pizza, or in this case the drugs, around the body in blood circulation, but only delivers it to the right address, the tumor site. One way to achieve this is to design carriers that are too big to enter the healthy tissue, but can enter the cancer tissue. And once they get there, these smart carriers will sense the presence of a certain protein and the acidity inside the cancer cells, which will break down their packaging and release the drugs. As a chemist, my job is to design and make this carrier with the right size so that it could accumulate at the tumor site and that it could sense that protein and the acidity. In my lab, using a model to mimic the physiological conditions, I have shown that this carrier is able to break down and release the drugs when those two factors are present. Then, with the help of a biologist in my team, I will be following the drug release pattern in different cancer cell lines. Of course, in real life, there are still many challenges that need to be overcome before intelligent drug delivery carriers can be used in humans to treat cancer. This is because cancer is not just one disease. There are many different types and many variations. But remember, using such carriers to deliver anti-cancer drugs has shown to significantly reduce their unwanted side effects in clinical trials. And this is why there is a lot of hope that with systems like the one I'm designing, Amy's dream of having beautiful long hair might actually come true. Thank you.
So, for our second speaker, her name is Melanie Nicole Juarez Velasquez. She's from the Environmental Toxicology and Pharmacology Group at the Institut National de la Recherche Scientifique, and she's going to talk to us about a human breast in a petri dish. She's an MSc student in year 2. She did her BSc in biotechnology in Mexico City, Mexico, and came to Montreal to do her MSc. Her research is mostly on animals in research as subject of heated debates, but they're also essential for progression unless we find a substitute. When she's not working, she likes to do Mexican folklore dance and will be dancing at Place des Arts in the summer. So look for her there. Right now, she's going to talk to us about her 3-minute talk.
Imagine yourself in a science fiction film in which a bunch of organs are created in the laboratory in some plastic containers. You will be seeing hearts, lungs, and kidneys being used to test some potential cure for diseases. In this futuristic scenario, we would have stopped using animals for research. Today, scientists don't always have a choice. We're required to use animal models such as mice to have a better understanding of diseases and the inside of our body. Only in 2017, in Canada, 4.4 million of animals were dedicated to research. That's almost 3 times the human population of Montreal. Moreover, interesting results from animal models might not be truly representative of what's happening inside a human body. So what if instead of using animals, we could have these mini organs for our research? Could that be possible? Let's say that we would be able to recover different types of cells from a human breast, and then put them within a secret mixture and have them magically recreate a mini breast in a petri dish. That could be awesome, right? But what could be even more astonishing is if we get this mini breast to produce milk. I mean, like real milk. A model such like this could allow us to test the potential harmful effects of toxic compounds. And if we are able to reproduce a healthy breast, we could also reproduce a cancerous breast to try new treatments on it. And why not find a cure? All of this while giving our laboratories mice their deserved break. So, does it sound interesting? Would you like to jump right into the future and bring this model to the present? Well, I have some good news. This whole science fiction story might not be as futuristic as we thought, thanks to my project. I am developing a mini version of a breast in a petri dish. So I take cells that once belonged to a woman, and I put them inside a gel that mimics the inside of our body, so that they will recreate the structures that they normally create in nature. It's like taking a fish from the ocean and putting it into a fish tank. You need to adjust their water temperature, their pH, the light, and find the fish prefers food, so it will happily grow. I do exactly the same for my cells. I adjust their environment so that they will feel as if they were inside a human body. So next year, by the end of my master, I can come around and tell you the end of the story. Hopefully, I'll have an optimized version of this model. And who knows, in some years, we may have all types of mini organs grown in the lab. Thank you.
Okay, that sounds like an exciting future. So now our next speaker, his name is Zanib Sharifi. She's in experimental medicine from McGill. And her title is New Strategy, New Hope. She's did her BSc in Iran, and then an MSc, came to Montreal in biotechnology at the McDonald campus. She's now in year 6 of her PhD program in experimental medicine in cancer research. She's here today to share with you some exciting news about her research on a novel strategy for the treatment of brain tumors. So welcome, Zainab.
What is the best gift that you can give to anyone? Imagine if you could gift someone time to live, to love, and to create. And time is treasure for a brilliant and young musician like Alex, who was diagnosed with glioblastoma. Glioblastoma is the most aggressive type of primary brain tumors in adults. More than 10,000 people each year die from this aggressive disease. Many drugs have been developed for the treatment of glioblastoma, but only few work. And from those drugs that work, after a while, patients do not respond to treatment and live for only 12 to 15 months. Why? Why is glioblastoma so hard to treat? There are two main issues in the treatment of glioblastoma. First, when you think of glioblastoma, think of T-1000 in Terminator movie. When you target it, it has the ability to change itself and overcome the weapons used against it and come back to life. But how can glioblastoma do that? You see, glioblastoma has a variety of ways to survive. So if you target one way with a treatment, it can use another way and continue to defile. Second, normally when we take drugs, it goes into our bloodstream, and from there it targets particular organs or injury sites in our body. But that does not work for the brain. Brain somehow reminds me of my younger sister that was picky about the food she was eating. Brain is picky about the chemicals it lets inside, and there's actually a barrier in place that stops the drugs from getting in. My research is to outsmart glioblastoma and to trick the cancer cells. So we combined two powerful drugs in one molecule and named it Combi molecule to be able to inhibit many survival pathways, leaving cancer cells with no opportunity to grow. Also, like my mom that had to make some changes in the food that my younger sister would eat it, we had to make some changes in the structure of the molecule and make it more appealing to the brain. I have some exciting news to share with you today. When I gave this drug to animal models, they live longer compared to the ones that did not receive this drug. Just like Alex, that got more time to orchestrate his life as a brilliant musician by going through a novel therapy in glioblastoma, by working on these thesis, I am keen to bring more smiles on glioblastoma patients' faces and their families. Thank you for your attention.
For our next speaker, her name is Melanie Boss. She's in the Sustainable Design and Engineering group at the University of Prince Edward Island, and her title is What Do Potato Chips and Climate Change Have in Common? Melanie is in the first year of an MSc at the University of Prince Edward Island, studying the environmental impact of potato chips. She did her BSc in Dalhousie in the agricultural group in Truro, where her interest in soil science was really piqued. She has a horse, one of four, named Patrick, but only Patrick when he gets naughty. Otherwise, he's Patty. So I'd like to invite Melanie Boss to give us her 3-minute thesis.
When you rip open a beautiful bag of crunchy potato chips, or when you plop that heaping scoop of mashed potatoes onto your plate, are you thinking about climate change? Why should you be thinking about that? Well, there are 3 main environmental impacts associated with potato cropping. These include nitrous oxide emissions, nitrate leaching, and nitrate runoff. One of these contributes directly to climate change, which in turn can increase the risk of the other 2. Let me explain. Nitrogen is one of the most important nutrients given to potato crops. It is often given in the form of nitrate. However, an excess buildup of nitrate in the soil is actually the root of the problem, pun intended. When the soil becomes wet, nitrate can transform into the gas nitrous oxide. This gas is a strong greenhouse gas that contributes to the warming of our atmosphere. In fact, it is 298 times stronger than carbon dioxide. Nitrate can also contaminate both surface and groundwaters. It does not stick to soil particles like other nutrients can. It can travel off the surface of fields with water into nearby ditches, streams, rivers, and wetlands. It can also leach down the soil profile into groundwater. The sloping topography and sandy soils found in beautiful Prince Edward Island allow nitrate to move to surface and groundwaters much faster. So sadly, elevated nitrate concentrations have been detected in drinking wells and streams all across the island, impairing water quality for both human consumption and aquatic life. Climate change is bringing more intensive rainfall events to PEI. Well, this could mean more nitrous oxide emissions, more nitrate leaching, and more nitrate runoff. While the effects of leaching and runoff have been seen locally, nitrous oxide emissions unfortunately have global impacts. Previous research has studied these 3 issues independently and the effects of weather events and nutrient management strategies on each. What is unclear is the interaction of these variables as they relate to topography. So my research, surprise, will be conducted in a potato field with varying degrees of slope. I will investigate the effects of different nutrient management strategies on nitrous oxide emissions, nitrate leaching, and nitrate runoff. My research will contribute, These strategies include applying fertilizer as one single rate, splitting the application of fertilizer, using a fertilizer that slowly releases nitrogen, and biochar, a charcoal-based soil amendment. My research will contribute to the development of best management practices that will prevent nitrate leaching and runoff and nitrous oxide emissions from agricultural fields. And finally, I hope that one day, when I devour an entire bag of potato chips to myself, I will do it with peace of mind, knowing I'm shamelessly consuming something that was produced with as little environmental impact as possible. Thank you.
Our next speaker is Ethan Armstrong from the Department of Biology at Memorial University of Newfoundland, and his title is Towards a Method of Detecting Benthic Aquaculture Footprint. He's an MSc Year 2 in Newfoundland, originally from Ontario, and he wants to talk about the detecting changes in oceans, why it's so difficult. Can machine learning help us understand the impact we have on the sea floor? When he's not doing this, he likes to drum metal music in the new No Name band, and he definitely thinks that AI is his in future. Right now he's going to talk about his 3-minute thesis.
As fisheries collapse, aquaculture becomes an increasingly important source of food for people worldwide. Aquaculture is commonly done by using cages that sit on top of the water, housing thousands of fish in a concentrated area. This intensive production results in uneaten food and feces settling on the sea floor, forming a layer of what's referred to as flocculent matter. This layer smothers life on the sea floor, and it impacts ecosystems for months, years, and in some cases, the changes might be permanent. Current methods of environmental monitoring include collecting sediment and underwater video. And while these methods are valuable, they take a long time to do. And it's important that we develop new techniques that can keep pace with this industry's expansion. Echo sounders are a potential alternative because they can survey larger areas faster than collecting sediment and underwater video. An echo sounder works by emitting a ping and listening for its return. The time it takes for the signal to return and the strength of the signal are both characteristics that we can use to identify objects in the water. So the question I had was, could we use data from an echo sounder to detect and discriminate flocculent matter from other substrates like rock and sand? Could we use sound to detect pollution on the seafloor? To answer this question, we turn to machine learning, which put simply is a field combining computer science and statistics, giving machines the ability to learn from previous experience. But before we could create the model, we first had to provide examples for it to learn from. And to do this, we overlaid echo sounder data with nearby images of the sea floor. The best model combining echo sounder data and spatial coordinates can tell the difference between flocculent matter and other substrates with 90% accuracy. When presented with novel information for an entire bay, a figure like this can be generated, showing predictions of where this footprint of aquaculture production is located. So, I've essentially spent the better part of a year building a pretty accurate feces detector. So the question naturally becomes, why does this matter? Well, a recent study looked at different ways of returning the seafloor to pre-aquaculture conditions, and the authors concluded, perhaps unsurprisingly, that the best way of doing this is by picking up the messes we leave behind. If we choose to do this in the future, my method can show us where to look and help our oceans recover a little bit faster. Thank you.
For our next speaker, his name is Adrian Herod. He's from the Microbiology and Immunology Department at Dalhousie University. He's originally from Burlington and did degrees in Ottawa before he came to Nova Scotia. During his PhD, he's in year 6 and hoping that this will be his last one. He completed a brief student placement at the Canada Food Drug Inspection Agency, which sparked his interest in foodborne pathogens and food safety. He likes to cook and eat, and he even does the dishes, and he likes to garden. But now he's going to tell us about his 3-minute thesis.
I love food. I also love to eat food. But food doesn't always reciprocate my love. In the past, I've fallen victim to the microscopic intruders that sometimes inhabit our food, forcing me to choose between either sitting on my toilet or being face first in it. I'm not alone, however, as it is estimated that 4 million Canadians experience foodborne illness every year. The mishandling of raw meat is partially to blame, but the larger concern is with contaminated food that we assume is safe. In Canada, contaminated food products are recalled from store shelves to protect consumers from foodborne illness. There are many microbes responsible for these food recalls, but the leading contributor among them is the bacteria Salmonella, and there are 3 reasons why. Number 1, there are over 2,600 Salmonella strains, and each are different from each other. Some can infect humans, some can't. We don't quite understand why, but we know that it is linked to their genetics. Number 2, other than chicken, Salmonella contaminates many foods, and some you wouldn't expect. Spices, lettuce, chips, chocolate, nearly no food is safe from the reach of Salmonella contamination. And number 3, our current diagnostic tests for Salmonella contamination are non-specific and look for the presence of any Salmonella. As a result, food contaminated with non-infectious strains is still deemed unsafe and is disposed of, leading to large amounts of food waste. Thankfully, diagnostics are improving. Now, instead of merely detecting for the presence of Salmonella, we can access the genome of the contaminating strain through DNA sequencing. But what can we do with the Salmonella genome? Well, I have a plan. I am currently studying the Salmonella-secreted protein H1, or SSPH1, which we believe could serve as a marker of infectious strains, as we have evidence that SSPH1 contributes to Salmonella's ability to establish infection. Additionally, SSPH1 is found in a minority of Salmonella strains. Therefore, if we can access the genome of the contaminating strain through new diagnostics, we can determine if SSPH1 is present and potentially if that strain is infectious to humans. However, we still need to identify the exact role that SSPH1 plays during infection. Once we know how SSPH1 contributes to infection, we will truly know just how dangerous that strain is. My hope is that using SSPH1 as a marker of infectious strains will reduce unnecessary recall and disposal of foods carrying harmless Salmonella. And while friendly Salmonella in our food may sound like an unappetizing idea, spoiler alert, many of the foods we eat daily carry thousands of microbes that have no negative impact on our health. But until we can routinely distinguish between infectious and non-infectious Salmonella strains, please pay attention to food recalls, handle your raw meats properly, and remember, there is only one way to cook chicken, and that is well done. Thank you very much.
Our next speaker is Kurt Ebeling. He's in the Department of Génie Biomédical at the Polytechnique Montréal. His title is Design of Diagnostic Gold Nanoparticles for Cancer Detection. He's an MSc Year 1. He did his PSc in Calgary in biochemistry, so he's come east. And his fields lie in the chemistry and physics engineering and the development of technologies for clinical applications. When he's not doing this, he's a competitive runner. 800 to 1,500 meters. He also plays guitar, so we have a band going on here, and piano, and he likes country. So right now, he's going to talk to us about his thesis in 3 minutes.
Nearly 1 in 2 Canadians will be diagnosed with cancer every year. It could be you, or it could be the person sitting right next to you. I'm not saying this to shock you, but I'm saying this to highlight the dire need we need for a more accurate cancer diagnostic tool. Currently, there's one conventional test for diagnosing cancer. This involves extracting a sample of patient tissue, staining it, and then adding a solution of antibodies. These are like molecules that are able to recognize and bind to cancer cells by their receptors, which is like a flag or a marker present on the surfaces of these cells. However, as we can see in this central image right here, most of the people in the audience here just see this as a purple smear. But I swear in the middle there, that's cancer tissue right there. It requires lots of skill, and it suffers from many drawbacks. First drawback, there's something that happens called non-uniform labeling. What does this mean? It means sometimes cancer cells go undetected. They don't attach to these antibodies. Sometimes these antibodies attach to healthy cells. Oh no. This is further complicated by the fact that our healthy cells express the same markers as cancer cells. Oh shoot. We need to be able to distinguish cancer cells from healthy cells. We can't do that. This just reduces the likelihood of an accurate diagnosis, increasing the likelihood it can be false non-diagnosis. And we know how cancer is so difficult to eradicate the later we diagnose it. What is one potential solution for diagnosing cancer? Gold nanoparticles. Ladies and gentlemen, when you hear the word gold, you're probably thinking of the image to your left right here, a gold bar. Very expensive, but I'm talking about a different form of gold on a nano scale. When assembled together, produce stunning visual properties that can be exploited by researchers to be able to visualize microscopic tissues. Second, they have a great versatility on their surfaces, meaning that we can attach a wide range of molecules on their surfaces to be able to design something that is specific to cancer cells. Lastly, they have the ability to be attached to a wide range of different molecules, a large number of antibodies, and this allows them to strengthen up, increasing the strength of the interaction. Imagine it as if the gold nanoparticles are going to the gym and bulking up. They're becoming stronger, which means they're more specific to cancer cells, which allows them to be able to be distinguished from healthy cells. This is where my project comes in. My goal is to successfully attach and correctly orient antibodies onto the surfaces of gold nanoparticles and be able to test the ability to detect cancer when compared to the standard test. Remains to be seen whether this becomes a new test or gold standard, pun intended, for the future. This should hopefully bode well for the future of cancer diagnosis and should be refreshing news for everyone in the audience here, for anyone that knows somebody that's been diagnosed with cancer. Thank you.
Our next speaker is Ruben Rodrigo Lopez Salazar from the Electrical Engineering Department at the École des Technologies Supérieures, and his title is Thinking Small to Produce on a Big Scale. Ruben Lopez is a PhD Year 3 candidate working on new ways to improve liposome nanoparticles production on an industrial scale. He did his BSc or undergraduate degrees in Juarez, Mexico, so he's a transplant. He likes to practice karate. He's currently a blue, but is hoping to go to a brown pretty soon. And he likes multiple disciplinary problems with a societal impact. So please welcome Ruben.
It is 7 p.m. You are at the doctor's office. She explains that it's an advanced treatment against cancer with reduced side effects. She gives you the prescription, you order the drug, but after waiting for months, it never arrives. In 2013, patients did not have access to a therapy based on a new type of carrier called liposome. Regulatory agencies stopped the production because of manufacturing and quality concerns. This medication would have given hope to many people suffering from the terrible collateral effects of chemotherapy. I am Ruben Lopez, and my research aim is to find a reliable way of producing liposomes. What are liposomes? They are tiny particles that help us to fight against cancer. Scientists create them to encapsulate medicine, like a balloon containing water. However, these balloons are 1,000 times smaller than a human cell, and because of their size, they accumulate selectively in tumors, attacking only diseased organs and sparing healthy ones, a magic bullet which targets only cancers. In our lab, we produce liposomes by mixing fat molecules, alcohol, and water. Theoretically, we could produce liposomes in a cup of coffee just by stirring this mixture. However, the mixing process would be turbulent. In some parts, the mix will occur faster than other parts of the liquid, resulting in liposomes of different sizes, making them unusable in cancer treatment. To solve this problem, we literally went to the bottom in scale terms by mixing at microscale, where the flow is smooth and without turbulence. This is accomplished by using miniature mixers that have channels thinner than a human hair. These small devices can mix in a uniform way, providing with exquisite control over liposome size merely by changing the flow conditions. In a similar way, we control the flow from a tap. So we can produce precise-sized liposomes which only accumulate in tumors. Besides, we can connect multiple mixer copies all together. A full-size liposome factory using traditional methods can be substituted with a block of just 20 parallel mixers that can easily fit on a work table. Right now, we control liposome size. The next step includes increasing production capacity, thinking on small scale to produce on a big scale. I expect that my research can give hope to those patients and families waiting for this wonder of science announced decades ago. Nobody should have to wait to have the best treatment available, because the future is now. Thank you.
Our next speaker is Barbara Balanova. She's from the Department of Chemistry at the University of New Brunswick in Fredericton, and her title is Color Tuning of Iridium Complexes. She has a chemistry and a BSc and MSc degrees from the Slovak University of Technology in Slovakia. She had her first year, 2 years of her PhD in the UK at Canterbury and Kent, and then her supervisor moved to Fredericton, so she's now in PhD 4, so 2 years in Fredericton. She likes to play the ukulele in the chemical band Chemists with Attitude. She also likes to do mountain hiking and yoga, but now she's going to talk to us about her iridium complexes. Thank you.
Picture this. You're holding your smartphone, unlocking the screen, and maybe scrolling through your photographs or just checking your Instagram. Can you imagine the nice, bright, vibrant colors? Have you ever thought about where these colors come from? Those are chemicals. And we as chemists, we can make them. We can make them the same way we're making pharmaceuticals. We can build them from scratch and modify their properties in order to prepare novel and more efficient systems. My PhD is about synthesis of metal complexes that are based on iridium. Iridium is a metal that can be found in the middle of the periodic table. An extensive research has been conducted on iridium complexes in the last few decades, especially for their application in organic light-emitting diodes, or as we call them, OLEDs. OLEDs represent a new generation for display technology, and it's predicted that they will occupy more than 35% of all smartphone devices by the end of 2020. There are many advantages of these materials. They are flexible, self-illuminating. You can prepare them in various sizes and shapes. And I believe that these are the reasons why only recently Apple ordered more than 70 million OLED screens from Samsung. My PhD is about color tuning of these complexes. Our methodology suggests to use just one system in order to gain multiple colors. The inspiration for this comes from nature. Similarly, as DNA is held together by forces that we call hydrogen bonds, I'm using the same type of force in order to bring my molecules closer together. The closer they are, fitting to each other like puzzles, the stronger they can influence each other. As we find out, this interaction is changing the properties of these materials. At least for me, the most interesting one is the color change. In the middle of my slide, you can see samples that I prepared in the lab. Through hydrogen bonding, we can modify the colors, but also enhance other properties of these systems. We can increase their brightness and prolong their lifetimes. Using just one system in order to reach multiple colors is a huge advantage of this methodology, reducing the costs of these materials, the preparation time, and in the end, making them more environmentally friendly. As someone famous once said, life is like a box of crayons, very colorful. And that's exactly how I feel about my PhD thesis. Thank you.
Our next speaker is Blair John. He's in the Industrial Organizational Psychology from St. Mary's University. His title is Catching the Fakers, Exploring New Methods to Identify Applicant Faking in Interviews. He did his BSc in St. John's and his MSc in St. Thomas in Minnesota, so he's a transplant. He's in the PhD year 2 of his program, and he's interested in how you can make detecting these fakers more of a reality than you would imagine. He likes to Latin dance, sports, and he likes to play Dragons and Dungeons, Dungeons and Dragons. Anyways, today he's going to talk about his new ways to attack fakers.
Let me ask you a question. Suppose you had to be 100% honest. Think Jim Carrey's character in the movie Liar Liar. And you couldn't lie, fake, or embellish on your last job interview. How confident are you that you would still be able to get the job? Ladies and gentlemen, my name is Blair John, and my research focuses on catching the fakers and liars in interview situations. Now, some of you may say, why should I care if somebody tells a white lie during a job interview? Everybody's done it. And the fact of the matter is, you're probably correct. The research suggests that as many as 90% of people have lied, faked, or embellished at some point during a job interview. But suppose the person doing this lying or faking was the doctor performing your child's surgery. What if it was the engineer designing that new bridge? Suppose it was the pilot on your flight out of Montreal. You can see how this would be problematic. So for my research, what we did is we had people come in and take part in mock interviews. We had them randomly assigned to one of two conditions. We had the honest condition, where we told people that they couldn't lie at all. They had to be 100% honest and couldn't lie, fake, or embellish. And we had the faking condition, where we told people they could say whatever they thought would make themselves look like the most qualified person for the position. Embedded in the interview questionnaire, there were two types of regular interview questions. There were past behavior questions that asked about their past behaviors in the workplace, and there were knowledge-related questions that asked about job-relevant expertise that they needed. But there was also two types of trap questions. We had the faking-resistant questions that looked just like the past behavior questions, but they also contained additional prompts about information that could be verified at a later date. And we also had the honeypot questions. Now, the honeypot questions, they were made to look like knowledge-related questions, except they asked about fake concepts that don't really exist. The idea is that if you're honest, you're going to say, I have never heard of that before in my life. But if you're lying or faking, you're going to say, yeah, sure, of course I know what that is. And our hypotheses were supported. We had three major findings. The first was that people could not decipher which questions were the real questions versus which ones were the trap questions, meaning these could be used to identify fakers. The second was that people seemed to struggle more with the honeypot questions than any other type, making them not want to lie or fake as much in that part or in other parts of the interview. And the third was that regardless of what condition we placed people in, they still lied or faked at some point, whether they were in the honest or the faking. So pulling all of this together, this is study one in a series of studies that we're hoping will allow us to better select the most qualified job applicants by weeding out those who lie and fake. And we're also hoping to use techniques like this in the future to detect groups with notoriously difficult to detect traits like corporate psychopaths. Thank you.
Our next speaker is Jujing Tang. He's from the Department of Medicine at the University of Montreal, and his title is Do Fireflies Belong in Research? So Jujing completed his bachelor's degree in biomedical sciences with a minor in mathematics at the University of Montreal, and then his master's in biomedical engineering also at the École Polytechnique de Montréal. He is currently in PhD year 6 and is hoping, yes, to graduate soon. He conducts his research at the CHUM. Aside from learning about science, he enjoys traveling and was most recently at Japan. And he likes noodles, is his favorite food, and laughing. So here we have Jujin.
Well, I really hope we save the best for last. But anyway, please don't worry. This isn't one of those quizzes on Facebook where 99% of you will fail. But actually, these equations should guide you to understand my thesis, and hopefully under 3 minutes. So without further ado, on to the first one. Here, we wondered, how can a firefly help us to better understand the lung? Well, to tackle this question, we do know that mitochondria are the powerhouses of the cell because they produce adenosine triphosphate, or simply ATP. Much like a rechargeable battery, this molecule stores and transfers energy, making ATP crucial for cells to live. However, through an unknown mechanism, cells can also release ATP, which seems kind of counterintuitive because why would a cell lose its source of energy? But in fact, once out of the cell, ATP has a different function. It is released to signal potential danger. Ooh. So for the second equation, we have ATP and a firefly. And of course, fireflies glow in the dark because they have luciferin and luciferase in them, which in presence of ATP will produce light. So if we surround cells with luciferin and luciferase, we can study ATP release because if we can see light, it means there's ATP outside of the cell. So for my thesis, we have developed an innovative method which quantifies ATP with the firefly's light. Therefore, at the third equation, we aim to measure this light. And to release ATP, cells need to be stretched. Now, stretching here isn't doing warm-up exercises before workout, but rather stretch is a strain or pulling force acting on the cell. And the organ that's constantly subjected to stretch is none other than the one that takes my breath away, the lung. So by studying light in the lung, we were able to bring the mechanism of ATP release to light. Well then, eureka. My research shows that as the cell stretches, its membrane is holding on for dear life, enabling ATP to leak out through holes temporarily formed during stretch. And finally, to sum up these three equations into the last one, my thesis studies the effect of stretch on ATP release in the lung and explains how cells can release ATP in response to stretch, all thanks to the fireflies. These findings are important to answer urgent questions, such as how can we prevent ATP from aggravating lung injury in patients supported by mechanical ventilation. To this end, I am delighted to say that fireflies do belong in research, which we hope will one day help sick patients to breathe better. Thank you.
Okay, I think we've had a great hour or so of terrific talks. Can we give all our presenters a welcoming and round of applause for a great series of talks? So now I'm going to ask the judges to leave the room so they can deliberate and pick what I think and try and choose the best three winners. I don't envy them the task. I think that was a phenomenal group of speakers. And at this time, what we'll do too is we'll open the voting for the People's Choice Award. So I want you to also, you here in the audience, to be looking at your sheet and deciding, oh boy, who was the first, second, third from this wonderful group of speakers. So we'll just take a few minutes, maybe 10, to think about that. And then we can take a break. We'll come back. And we'll have some Q&A with the presenters. I think they need a break. What do you think? Okay, so we'll take 10 minutes and then come back. Choice Award here. Check the box next to the name of the presenter that you received, and then hand your ballot to Sarah and April here at the front. Do that within the next 10 minutes so they have a chance to collate them. Okay, you have 10 minutes to do this. After this time, you've lost your chance to vote for the People's Choice Awards. If I could just ask all the presenters to come up on stage, we'll now go to the Q&A part. This is where you, the audience, can grill them. Not that they are nervous or anything. In no particular order.
Somebody asked us to be in order,
Oh, really?
just for the mics.
Hey, you have to go in order for the mic. Okay, audience. There'll be people coming around with a microphone, so you can ask your question, and this way it gets to be heard in the room and also on the video. So, can I have a first questioner? Down there in front. Maybe say who you want to direct your question to.
Hello, actually I have a question directed at everyone working with very small scale medical devices, nanoparticles, things like that. Can you comment on the manufacturing or sourcing of the materials needed for your research? So I think nanopolymers, gold particles, and where do you actually get these materials from?
Start from left to right.
Okay, so I'll start. Well, I'm working with polymeric micelles, as you mentioned. So we actually synthesize the polymers in our lab because it's a polymer chemistry lab. So we synthesize different polymers. Some of them are a little bit more like natural polymers, like polyesters and polylactides. Some of them are a little bit more like synthetic, like methacrylates and all, but we definitely synthesize them from scratch, yes.
Next nano guy.
I can answer. Okay. So for the time being, I'm working with nanospheres. It's not the goal of my master's project to produce nanoparticles, but there is a PhD student who specializes in nanomaterials, and she's producing nanospheres that are actually, they're called core shell structures, and they've got silver, gold. I might also be working with nanorods, nanopyramids, nanostars. There's a lot of different types of different nanos things, all for the same end goals.
Okay, I'm working with the liposomes. Yep. So in this case, lipids that form the liposomes, we buy it from a supplier. Being said that, also there are other type of amphiphilic molecules that you can use to create a sphere structure. So most of the time you just buy them, in my case, for liposomes.
More questions? Lady in the back. Lady in the middle.
Maybe you can
Yeah.
hear me.
Yep.
Yeah.
Yes.
I taught here, so you know what. Right.
Cool.
Oh, you're recording.
Yeah.
Okay.
Yeah.
Sorry.
We'll do the relay race thing here.
Sorry, I can't get out. Yeah, first of all, congratulations to all of you. You were amazing. What I'd like to know, and this can be for anybody, I know a little bit from the last round that we had here at McGill about a month ago about the amount of training that went into getting to this point. And I'd just like to know from whomever, what was the most important aspect of that, of getting involved in this procedure and working through what you did to present your wonderful 3 minutes? So anybody like to start? What's the biggest takeaway?
For me, I think I do Toastmasters, so I practice my speech, and something that I always have admired is really good orators. So for me, I was looking at this more as an opportunity to practice because this research I'm actually presenting in Europe in a few weeks. So I said, okay, I'll just go and practice at my university, and it just ended up turning into a thing. So then having supportive professors, they also encouraged me and kind of ran me through it. I had to go through my data and redo parts of it actually, and I have a slightly different outcome for this presentation than I did at my initial one because I was still in the process of conducting my data analysis. So I would say probably practicing my speaking and then knowing how to break it down in a way that somebody who is not familiar with my research can grasp pretty quickly.
Yeah, that's what I really admired with each of you, that I could understand what you were saying and from a diverse, different backgrounds. Anybody else? Yeah.
Also, I have two takeaways. The first one, I mean, it's very important to have the trust and the help of family and friends, that they are there to help you, to listen to you the 100 times that you're going to practice the same speech. And that's something that it's like a takeaway for me. I really appreciate all the support of family, friends, my university. And also the reason that I'm here is because I really want to give the message of the importance of research, and now more in a days in which there are certain societies that they are taking science as something that like fake. So I think it's very, very important for all of us to give the message, to give the message to the society, and also about the importance of keeping doing research in a way that we can help all the people around.
Yeah, that was very clear and very, very important. Yeah.
You go for it. Yeah? Okay. So there's lots of things, of course. I think the main thing was getting that mentorship and feedback from so many different people. I think we can all agree here that evaluating something like this is really subjective and requires opinions and second opinions and third opinions and fourth opinions and so on from so many different types of people. I was looking at, I had a mentor for an entrepreneur. She was with lots of experience writing pitches and speeches. She was providing me with some feedback. I go to Toastmasters as well, just like Blair. That was also a great way to diffuse the information to the public and see how they react and see how they interpret what I'm actually trying to get by through them. Lastly, I think the most important thing is the motivation behind and why I'm doing this. I think it's all about putting into practice, and I think I'm very passionate about science communication and dispelling a lot of the rumors and the myths that are regarding science right now. Mm-hmm. Let's just look no further than the measles crisis that's going on right now, right? So that's what really drove me to do this today.
Wonderful.
I just wanted to echo that, but also this is an opportunity for us to develop, as we often hear, elevator pitches. And so whenever we go home or we meet someone there and they ask us what we do, this is just a tremendous opportunity to actually develop that in a way that almost everyone can understand. And so right now, I have a 3-minute video that I can send my parents instead of me going home for whatever holiday and trying to explain what I do. So, yeah. I mean, not as personal to send in a link, but it still works.
What about some of the ladies? Yeah.
So what helped me is I like to follow the principle KISS, so keep it simple, stupid, and trying to explain it or getting comfortable with explaining your research to various audience, not just adults who know what you're saying, but kids and my grandmother, and yeah, so I just like to try and follow that.
Yeah, wonderful.
I think that this exercise helps us all to get like out of our comfort zone, because we're so used to present like in scientific congress and our posters and our presentations in the lab, so you're used to the scientific vocabulary of it, and you sometimes forget that you're actually doing the research for someone that's not in that room.
Right.
So you need to be able to tell your story without bringing words that someone needs to go and search in the dictionary.
Yeah. Wonderful. Well, thank you. I was joined Toastmasters before you guys were born, and I'm still a member because of the mentoring, because of what it does, and all of that. So thank you again for wonderful presentations.
Thank you.
That was a terrific question. Any other questions? Oh, lady down here. Oh, fellow up there.
I see a lot of passion and a bit of a wordsmith, and I think you all accomplished the clarity, and I think that's so much so important. For those that can answer this question, what do you see the prospects of graphene in the future?
Can you repeat the question? What do they?
What do you see as the future of research, your research?
What applications do they think they'll have using graphite, either in tubes or qubits or spheres?
Oh.
Pretty much a new field. One person
Graphite.
it's a great field for learning microprocessors.
Maybe you could explain what graphites are, you person identified, and then the others can jump in. Yeah, go ahead.
Well, the graphite I'm thinking of course, is the graphite you see on a pencil, but I'm going to try to attempt to... Graphene.
Graphene.
Graphene. Yeah, it's graphene, okay. Well, that doesn't apply to me particularly, so I don't know if I'm the best person to answer this question, but I'm going to say that nanotechnology is an exploding field right now, and there's lots of different nanomaterials that are coming out. And if I'm not mistaken, there are some various properties that can be used for graphene that can be used for drug delivery, being able to also, not necessarily in detection because they don't have the visual properties, not optical, to be able to be used. But that's the best answer I hopefully can provide for you.
Someone else?
We have worked with graphene oxide, but just at a very exploratory level. What we have seen is a very interesting interaction with cancer cells and also normal cells. So what I can see is first there are all the applications that are being developed in graphene oxide, and also as part of our job is to identify how the graphene is going to interact with living matter in the future. So I think there are two big challenges to tackle there, and I'm not sure that it is going to be as fast as the media sometimes portrays, that the things are going to be there as always. But I can tell you that a lot of work has been done in the field.
We had another question.
Hi, I just want to say congratulations again. This is a wonderful event. I'm in the humanities here at McGill, and I've noticed that almost all of you are in the sciences and in the social sciences as well. So it's really fascinating for me to, come to a space where science is being communicated really clearly for somebody like me without a lot of experience. Another thing I noticed is a lot of you have really rich creative lives. When she was describing your biographies, you're playing with narrative, you're playing with performance, you're playing musical instruments. I wanted to know a little bit how your creativity may inform your research, or if there's any sort of dialogue there.
Mr. Drummer?
That's a tough question. For my whole project, I worked alone. Everything was self-taught. I was given this data, and I was kind of expected to make a project out of it. And I was really afraid of just failing, not being able to give my supervisors a good answer. And I found a really good feedback loop with playing music, because my drums, they're electric drums because I live in an apartment. I'm not an animal. My electric drums are right behind the lab computer pretty much. So I'd be working and I'd get stuck on something and I would just spin my chair around and play drums as long as I didn't want to do work. And I think it did help because I think it activates, I'm not a neuroscientist, but I think it activates different brain areas. Maybe it massaged some good ideas out of it. I hope I answered your question.
Guitarist?
So maybe I'll just add small things. So I'm a part of a group named Research Information Outreach. So I'm part of the youth outreach. So we go to schools and we talk about cancer to kids. Normally kids, kindergartens or high school students. And that I really think that helped me a lot to really simplify my words when I talk about cancer in general, and also about brain tumors, which is really complicated, and also when it comes to drugs, it's very complicated. So I think that
really what really interests you somehow would help you to develop these kind of presentations, and I totally agree.
I will just add that I guess science, in any type of science, it's a pathway like that goes like up and down continuously. So I guess that, at least for me, doing something extra or like out of the lab give me like a breathe, take out the thoughts of did it work, did it didn't work, tomorrow I need to repeat the experiment, I need to adjust and change and modify and come with a new plan. So every time, since you are in this continuous fight or love war with your project, it helps you to have something else to kind of breathe, and then just, as you were telling, just massage the brain and say, oh, that's a good idea. So
This is going to sound pretty terrible, but coming from a 6-year PhD student, you almost learn to be fine with failure. So I failed a lot. And so it's nice to have things outside that you know you can do right to make you feel good. And just to clear the headspace too. So like I mentioned, gardening. Cool. Like if you screw that up, then you're not going to have food to eat. I mean, that's not your only supply, but it's like it's certain things like that. So it just takes your mind off of it, and when you're able to clear your headspace in that regard, that's sometimes when you have those moments of clarity, when it's those eureka moments, you know? So it really helps in that regard.
For me, I probably sound, oh, sorry.
No.
I probably sound like I'm obsessed with horses, but it was nice to have my horse there on the island with me. I have 3 back home in New Brunswick, so it really helped to bring one of my horses over. It was kind of a nice reminder that when I was getting really frustrated with work and stuff, he had no idea, and he was just happy to see me. So kind of nice to have that little reminder that someone isn't really depending on your research, and yeah.
I'll be brief here. But yeah, I would like to repeat basically the same points that everyone else had said before. Again, it's clearing headspace. Now, fun fact, I guess this is more of a byproduct of being more of a musician on the creative side of things. I found that it has given you the ability to have more sensitive hands with science, and science is a lot of handwork, and especially like I'm handling like a dialysis membrane or something, and I need those fine fingers and those fine motor movements, and I find music has some translatable skills into the science. So something that maybe unintended, but definitely a side effect of playing music.
It doesn't work like that when you are after a karate lesson. It's a little bit shaky.
Yeah, sore hands. Don't drink coffee before handling a dialysis membrane.
At the back there?
So this is a question for the whole group here. What did you find most surprising or unexpected about, say, your presentation style or about scientific communication generally throughout the process of training and competing?
Any particular person?
No, the whole group. One by one.
I'll say that the most surprising part is that when I was creating my speech, I first came for feedback with my group, like my lab group, and we were just hanging in the same idea because we're so used to listen to each other, and we're so used to be in the concept that we lose the dimension, we just forget the dimension of what we're doing. So whenever I talk to someone else, like my dad, I just told the speech to my dad, and he was like, "Oh, but that's amazing," and that's like, "Are you actually doing that in the lab?" I was like, "Yes." But I think that the most impressive part of me is we all scientists are doing something that it's counting. We are adding a bit of a rice in the top of the bag of rice of knowledge, that actually will count for something. So for me, it was one of the best things that I took from this exercise, that it counts, what we're doing counts.
I think for me, it would be that the scientific community or academic community can feel really insular, like you spend so much time in a lab with the same people doing pretty much the same things as you. So you're very used to communicating to them on that level. But they always tell us this, at least in my program, is that when you go into the industry, they're not going to care about your standard deviations, they're not going to care about your percentages, and probably not about all your stats. So you need to be able to find a way to convey what those mean in a meaningful way. So I guess it's just, how do you take that knowledge that you're so used to being very academic and very scholastic with it, tell somebody how that actually matters or why they should care about that?
And also, not just conveying the ideas, but also conveying all the passion that is behind the research that you are doing. I think is one of the hardest part to do, because I think all of us, we understand that we try once, we try twice, we try thrice, 1,000 times. And also it's important to transmit that passion to the audience that is listening to us. So I think it's one of the most challenging parts is to transmit that in 3 minutes. Yeah.
Can I just add one thing? That I think the most surprising thing here at 3MT, and I think everyone will probably agree with me on this, is that we learned that it's not just about your words. I mean, we're so used to, again, going to conferences and we talk about our research and they judge us based on the knowledge. But here, we have to, in 3 minutes, just with our voice and with our hands, with our gestures, with our emotions, we are supposed to transfer all the feelings that we went through in years of research, and you're supposed to feel that. And I think that was surprising. At first, I found it very difficult, but I think now that we're here, it's very fulfilling.
Yeah, that's true. Like, I always thought that I need hours and hours to talk about my research, but not really, you know, like if you really think about it, you can summarize it in 3 minutes and even less. So, yeah.
Thank you.
Okay, I think we'll close the questions because I see the check. So, before I announce the winners, I'd like to thank our judges for today. I think they had a really hard job. So, let's give them all a big welcome. Big round of applause. I'd also like to thank all of our presenters. You are fabulous. I mean, you have no idea how wonderful it felt to listen to you, to hear all the great things you have done, the things you think you're going to do and are planning on doing. Obviously, you're very passionate about your research, and I wish you were all in my lab. You know, all of you did a great job. It's very exciting to hear about these kinds of things, and it's energizing not only for you, but for the audience and for everyone involved as well to hear this kind of excitement and passion about their research. So thank you for that. Please hold your applause after this because we have some other people to talk about too. First of all, this event was planned by the team at SkillSets. Raise your hand. Down at the back there. And GPS, Graduate and Postdoctoral Studies. So I want to give them a special thanks to Alistair Hibbert, who is not here. He's moved from Montreal to Alberta, you know. So, you know, last week, you know, kind of thing. So anyway, so he's been an outstanding leader in this for a number of years, and we actually do wish him well. The people at SkillSets and GPS include Alex Lipins, Alex Gavrila, Sajina Jasanjis, Sarah Adams, Sophie Marie Schomburg, Marie Jo Rahal, and April Bobby. I'd also like to thank Robin Obermeyer for designing the event program. It looked really good. All the pictures came out. Our fantastic photographer, Ben, the wonderful video team on site here today, very professional group, and led by Stu McComey. So I'd like to give all of our helpers here a huge round of applause. I'd also like to thank Sonia DiMello, one of our judges, who has made a gift of copies of her book, An Apple in the Orchard, as part of the winner's packages. So thank you for that. Very generous of our judges. So thank you for her. So, finally, because we love clapping, we're going to give a really big hand to the presenters. I think they did a terrific job. They answered all your questions. They were on time. Nobody went over time, so can't imagine how hard that must be here when it's a little hot up here. And I'd like to give them a warm thank you. So now comes the hard part. First, what we're going to introduce the People's Choice Award. So, Sage has their certificates, and I think she'll be running up with them shortly. Oh, I was also supposed to invite the judges on stage. Sorry for that. So come on up.
So I'll ask you just to scooch down just a little bit, please. Thank you. Sorry about that.
That's okay. No, I had misread the directions. There were directions.
Okay. I just like to pretend to do it.
Okay. So Sage is not going to do it?
No, someone took over accidentally.
Oh.
So they're in order. It's just standard to second to first. Good?
Yep. So I get this pleasure. So the People's Choice Award goes to, we need our drum roll.
Electric drums, no less.
Pardon me?
Electric drums, no less.
Yeah, I know, eh? Ruben Rodriguez Lopez Salazar. Congratulations. And the third place prize, and a check, goes to Nusha Arezi. And the second place prize goes to Adrian Herod. And the first place prize goes to Jujing Tang. Yeah.
It's a big one.
Yeah. Before we go, I'd like to present our judges with a token of gratitude because they had to work really hard. Okay, so thank you again for the students. I'd like you all to stay up here with the judges so we can take some group photos. So this is, go for it. While he's doing that, I'd like to say it was McGill's absolute pleasure to host these Eastern Regional competition. The presenters here provided us with some really wonderful talks and some inspiration. And I'm glad that we're able to have you all here today, too. We hope that you've enjoyed the experience. I know that we have all enjoyed hearing the presentations from this wonderful group, and we're excited to hear, and we'll be waiting to see what kind of things they can do in the future. I also want to say thank you to the audience, both here and online, for joining us today and supporting these students. I know your support means a lot to them, as they've mentioned how crucial it was to getting them to this point. Now we have a reception with food and drinks just outside the hall, the 2 doors to your left. Some of the organizers will be there to direct you there. So great afternoon, and we'll see you in the reception. Go.
Thank